So in this video, I want to talk about the problem of the paging and segmentation that may cause the issue in the virtual memory. So basically, we can see that paging is subject to internal fragmentation because a process may not need the entire range of addresses that contained within the page. That's there may many pages contain unused fragmentation memory. On the other hand, the segmentation is subject to external fragmentation, where the which occur when the contiguous chunk of memory become broken up and the segment are allocated and deallocated over time. So let's consider a simple example. We assume that a small computer having a 32 kilobyte memory and where 32 kilobyte memory is divided into each page frames that each of them contain a 4 kilobyte each. Okay, so here the representation of the memory. So we can see that the number at the right here that the memory frame addresses from 0 to 32. So each of the page frame right here is 4 kilobyte. Okay, and you can see that basically the schematic of the configuration of the computer. So suppose we have 4 processes waiting to be loaded into the system with the memory requirements as the shown at the table right here. We have the processes name of P1 to P4 with the memory needed 8 kilobyte for the P1, 10 kilobyte for P2, 9 kilobyte for P3, and 4 kilobyte for P4. So we can see that the total requirement of the memory needed for the 4 processes, that the 31 kilobyte. So basically this one smaller than the system memory capacity. So this actually should be fit into the memory. However, we can see that due to the fragmentation, that's impossible to fit all of the 4 processes into the memory using the paging. Okay. So here's the problem. We can see that when the first 3 processes are loaded into the memory, gonna look like this. P1 gonna contain the first 8 kilobyte right here. P2 gonna take the next 10 kilobyte, and we have the one frame right here, one frame right here, and another half frame right here. That's for P2. And P3 gonna take another one because this one gonna be a 9 kilobytes. So it's this one is gonna occupied by the P2. So P3 gonna take the from the address of the frame address 20 kilobyte right here, and gonna all the way to 29 right here. So you can see that 3 kilobyte right here and 1 kilobyte right here gonna be a remaining for the P4. Okay, so we can see that that's gonna be a problem because even there's enough 3 byte 4 kilobyte, but P4 have to wait for one of the other 3 to terminate because there are no unallocated frame that's gonna be fit for the process P4. Okay, so even you can see that 1 kilobyte here and 3 kilobyte right here, the total is still a 4 kilobyte, but this cannot be used to allocate to P4 because of the location of the memories in different position. Okay, so this problem is that we call the internal fragmentation, because some part are gonna be occupied of the one of the page of different process right here. Okay. On the other hand, so now we assume that instead of a frame, our system of 32 kilobyte use the segmentation. So basically the memory segment of 2 processes are shown at the table right here. We have the process P1 and P2. We have P1 have the S1 to S3. That's the segment with the memory needed 8 kilobyte, 10 kilobyte, 9 kilobyte. And for P2, we have the 2 segments S1 and S2 is a 4 kilobyte and 11 kilobyte. Okay, so the key thing is that the segment can be allocated anywhere in the memory. Okay, so with that scheme, we can see that all of the segment of P2 and one of the segment of P2, all the segment of P1 and all segment of P2 are possible to be loaded into the memory. So you can see that P1 S1 right here gonna take 8 kilobyte. P1 S2 gonna take next 10 kilobyte. P1 S3 gonna take next 9 kilobyte, and P2 S1 gonna take next 4 kilobytes. Okay, so this one you can fit a 31 kilobyte into the memory and 1 kilobyte right here. So definitely 1 kilobyte remaining right here is not fit into the segment 2 of the process 2, so that require 11 kilobytes. So the this segment need to wait until one of the segments will be free. Okay, so now we assume that the segment 2 of the process 1 right here is no longer needed, so it is unloaded and giving a total of 11 kilobyte free memory. Okay, so 10 kilobyte here and 1 kilobyte right here. Okay, however, we have the problem in this case. Segment 2 of the process 2 still cannot be loaded because the free memory is not contiguous. Okay, because one power here, another power here, so it's impossible to load the information of the segment 2 of process 2 that require 11 kilobyte. So we can see that over time the problem gets worse. That resulting in a smaller unusable block scattered throughout the physical memory. So we can see that maybe one power here, another power here, another power here, and another power here. So that's gonna scatter all around the throughout the physical memory. So this problem we call that the external fragmentation, and eventually this memory is recovered through the compaction and the process of start over. So that's required restart and reset everything. So we can see that large page table are cumbersome and slow, but with its uniform memory mapping, the page operation are fast. On the other hand, the segmentation allows fast access to the segment table, but the segment loading is the label intensive. The next feature is that the paging and the segmentation can be combined to take advantage of the best feature of both by assigning the fixed size pages within the variable size segments. And also each of the segments have a page table, so this means that a memory address will have 3 fields, one for the segment, another one for the page, and another one for the offset. Okay, so that's basic some information about the virtual memory. So some more detail about the virtual memory and can be found in the textbook.